All right, so we are on to our last unit, which is trigonomic functions. Now, some of this is supposed to be, more than half of this should be grade 9 or grade 10 review of trigonometry. And the other parts, there will be some new stuff. So again, 2020, not sure how much trig you did back in those in grade 10. But again, I'm going to start from the top. So I'm going to pretend that you've never done trig before. But again, because you should have, I will probably go a little quicker than I would in grade 10 when I'm teaching trigonometry. All right, so what we're going to look at here first this morning is finding the sides of a right triangle. All right, now with a right triangle, you have to have a 90-degree angle. That's what makes it a right triangle. Now, with trigonometry, there is two other angles, and one of those angles is going to be the angle that you're looking from. All right, now, in trigonometry, there's three sides to a triangle. Hopefully, I'm not surprising anybody there, but those three sides have names, all right, specific names. Now, the side across from the right angle is your hypotenuse. All right, the side across from the angle we're looking from, which again I call a Greek letter theta, not just me, but textbooks. All right, across from that angle is called your opposite. And the third side is called the adjacent. Now, I struggled with trigonometry in high school because, first of all, I didn't know what adjacent meant because I'm not very good with English. Adjacent means beside. And so this is the side beside the angle. All right. But in fact, there's two sides beside the angle, but one of them is always going to be the hypotenuse. And so that makes the other one the adjacent. Now, there are three basic trig ratios that you have to know. Now, with a ratio, this is something I teach in grade 10. A ratio can be written as a fraction. And in trigonometry, I don't know why they don't call them trig fractions, because that's essentially what we're going to be dealing with here. And there's three of them that, three basic ones. The first one is the sine ratio. The second one is our cosine ratio. And the third one is our tan ratio. Now, I'm going to leave a little bit of space here, but the sine ratio is how we write it is sine or sin theta, which means I'm looking at using the sine ratio from this angle theta. All right, and that ratio or fraction is when you take the opposite and you divide it by the hypotenuse. All right, the cosine ratio, which is short form to cos theta. Again, this is a cos ratio looking from the angle theta. It's always key. You're looking from either this angle or this angle, never looking from the right angle. The cosine ratio is the adjacent divided by the hypotenuse. All right, and then lastly, our tan ratio. Tan theta is the opposite divided by the adjacent. Now, how in the heck do I remember those? What I do is I have three memory phrases that I use to memorize. I'm not a big memorizing fan, but unfortunately you do have to memorize these. And so for the sine ratio, I use the phrase sine on highway. Where what I use in that phrase is the first letters in each word to tell me what the ratio is all about. So the sine ratio on highway, opposite divided by the hypotenuse, the O and the H. That's what I'm using to memorize it. Cosine, I use cozy at home. All right, so again, cozy, cosine, at home, adjacent divided by the hypotenuse. Tan on arms is how I remember the tan ratio. All right, so tan on arms, OA, opposite divided by the adjacent. Again, there is other phrases that people use. I think the other most familiar one is SOHCAHTOA. But as I mentioned earlier, I'm not very good. I wasn't very good with English and still I still don't know how to spell Sokotoa. So that was always a problem for me. And plus with Sokotoa, they're all three of them are jammed in together. So if I miss one letter, I'd be in trouble. So again, these are the three memory phrases I use. All right. Sign on highway, cozy at home, tan on arms. Now that again should be something you touched on in grade 10. Again, I don't know if that's true or not. Here's something new, is that these are the three basic trig ratios. Well, there's actually three more, and they're called our reciprocal trig ratios. And what reciprocal, if you're unfamiliar with that word in math, is when you invert something, flip it, like a fraction, 4 over 5, 5 over 4 would be the reciprocal. All right, so in this case, there's three more because there's one for each of them, where each of these trig ratios or fractions get flipped. They're reciprocal. The first one is your cosecant, which is written as CSC theta. All right, that's the short form, just like sine, or sine, S-I-N-E is the short form is S-I-N. Well, cosecant, CSC, and that is when you take your hypotenuse and you divide it by the opposite. All right. The next one is secant. Secant theta, secant, which again I'll short form to SEC theta. And it is the reciprocal of our cos, which means I'm going to flip the cos ratio. And so I have the hypotenuse divided by the adjacent. Again, just flipping the cosine ratio. The cosecant, flipping the sine ratio. And then the last one, tan, if I flip the tan ratio, I get what's called the cotan ratio, which will be COT theta, short formed. And again, it is the tan ratio flipped. So instead of the opposite divided by the adjacent, I have the adjacent divided by the opposite. All right, so we have our three big basic trig ratios, which you will see on your calculator. They're there. But then we have our reciprocal trig ratios, which are not on your calculator. So we're going to learn how to deal with that. All right, so here we go. So there's our basics of trig, our 6 ratios, our naming of our sides. Now let's get down to figuring some stuff out, hopefully jogging some memories. But we'll start off with the basics of just working your calculator. All right, so here we go. Example 1. Find the value of, let's see here, of the following. So we got A, sine 40 degrees, B, cos 50 degrees. We'll get to C and D, a little more involved. All right, now sine 40 degrees and cos 50 degrees, this shouldn't be anything new, but again, there's some tricks to it. Well, not some tricks, just some things. The first is your calculator in this unit has to be in the right mode. I don't know how many times I'm teaching this in grade 10 right now. You can press all the right buttons, get all the wrong answers if your calculator is not in degree mode. So on your calculator, you should have a little D or a DRG or DEG. Your calculator must be in degree mode. Otherwise, when you hit sine of 40, you will not get, what am I getting here? 0.62. Now, I would say that 70% of calculators, maybe even 75% of calculators, you just hit sine 40 degrees and you get 0.62. The other half, or the other quarter of calculators, which I don't like, is you hit 40, then you hit sine. All right? You have to figure that out in your calculator. so you can get the right numbers. Make sure it's in the right mode, and you should get 0.62. All right. The modes you don't want to see are like R, RAD, G, GRD. You don't want those. Those will not work for you. All right. So it's got to be degree mode. Now, so if I press cosine 50 degrees, again, my calculator, I do hit cos 50 degrees, and I get 0.64. There we go. Now, here's something new that you've never done before. I would assume you've never done before, is the other ones. For instance, C, cotan of 30 degrees. All right, now, as I mentioned before, our three basic trig ratios are on your calculator. The other three reciprocal ones are not. So here's what we have to use. We have to use those three basic trig ratios buttons to find cotan. So the reciprocal of cotan is tan. All right, so what I'm going to do is I'm going to type tan 30 degrees into my calculator. And when I type tan 30 degrees into my calculator, I get 0.58. All right, again, that's assuming that your calculator is in degree mode and you can press this in. Now, that's not what cotan is. Cotan is the reciprocal of that number. And so if I take 0.58 and I can write it as a fraction, I can write any number as a fraction by dividing by 1. And so now, because I created a fraction, cotan 30 degrees is going to be the reciprocal of that. So instead of 0.58 divided by 1, cotan 30 degrees is going to be 1 divided by 0.58. And then I can take that, put that in my calculator, 1 divided by 0.58, and I get 1.72. And again, that's because cotan is the reciprocal of tan. All right, I'm going to try another one of those. Again, a little something new. D, I got the secant of 60 degrees I'm looking for. So again, you have to know that secant is the reciprocal of cosine. So what I'm going to do is I'm going to type in cosine of 60 degrees in my calculator because I can do that. All right, and I type that in and I get 0.5. And again, I'm going to make that a fraction by just simply dividing it by 1 because everything divided by 1 is itself. Now, because secant is the reciprocal of cosine, I'm just going to flip that 0.5 and that 1. So I have 1 divided by 0.5 is the secant of 60 degrees. I take 1 and divide it by 0.5. The secant of 60 degrees is 2. All right, so that again is how we're dealing with our reciprocal trig functions. Now, to get back into where we're looking at is finding the lengths of sides of a triangle. So again, this part hopefully is review for grade 10, but again, I'm not sure what you did. So here we go. We'll do a couple of examples, hopefully jog your memory. If not, well, I guess you're learning it for the first time. No big. All right. So you've got to know your trig ratios, your primary trig ratios. You don't need to know your reciprocal trig ratios to solve the following problem, where we have, let's see here, example 2, where I'm going to, find x. All right, so I draw my right angle triangle because that's what we're dealing with first off today. So there we go. There's my right angle triangle. I have a side here of x. I have a 250 here for a side. And my angle, which is always on the inside there, is 75 degrees. All right, so here's our triangle. Again, it's a right triangle. Has to be for what we're doing this morning. All right, now here's your first step. Your first step is to write down what information you have. All right, now the easiest one is the angle. It's telling me it's 75 degrees. But now I have two sides. I have a 250 and I have an x. The key here is I have to determine in terms of trigonometry what sides I have here. There's three of them again. We have the opposite, the adjacent, and the hypotenuse. These sides have to be two out of those three. All right, so what I again look for is I got my right angle, and always the side across from my right angle, that is always my hypotenuse. So my hypotenuse is 250. Now, the next side I always look for is I have my angle. This is the angle I'm looking for here, or from my 75 degrees. I go across, and that is my opposite. I don't have it. So there's only one other side that this x could be, and that is my adjacent. It is the side beside the angle. So is this 250, but again, this 250 is my hypotenuse, which then makes my x my adjacent. That's the first step. Write down your given information. The second step is figuring out which trig ratio I have to use. Not which one I want to use, which one I have to use. There's only going to be one trig ratio that involves, one basic trig ratio that involves the hypotenuse and the adjacent. So again, that's where I use those memory kind of keys for me to figure out which one I got to use. Sine on highway. On is the opposite. I don't even have the opposite, so it can't be sine. The next one, cozy at home. At home. I do have the adjacent and the hypotenuse. So I have to use the cosine ratio. So I have cosine theta. At home, cozy at home, adjacent divided by my hypotenuse. So there we go. I figured out which trig ratio I have to use. The third and final step is plug your information in and solve for x. All right, so here's what I've got. Cos, the angle is 75 degrees. So I got cos of 75 degrees is equal to, again, I want to make sure I get everything right here. Adjacent is x, and the hypotenuse here is 250. There we go. So I've subbed in my information. Now it's time to solve. Cos 75 degrees. We've spent some time in our first example finding that. So again, that's just pressing cos 75 degrees. Assuming you've got it in degree mode and you're pressing it properly, I actually get 0.26. Now, the next thing I'm going to do is a trick that is going to be used pretty much the rest of this unit. All right, and that is I have 0.26 is equal to x divided by 250. I'm going to create a situation here where I have a fraction equaling a fraction. All right, so I'm going to make this 0.26 a fraction by again dividing by 1 because that doesn't change the number. Because any number divided by 1 is itself. Now, the reason I do have a fraction equaling a fraction is that it helps me easily solve for x because the easy way to get out of a fraction equaling a fraction is that you cross multiply. So I'm going to have a 1 times x, which is just x, and then I'm going to have a 0.26 times 250. And when I take 0.26 and I times it by 250, I'll get my x. And in fact, I'm getting 65 right on, actually. And there we go. All right, I'm going to do one more of those. Hopefully, again, it's jogging your memory. All right, so here we go. Second example, or third example, I guess, today. We have, here's our triangle here. I have, here we go. Again, it's got to be a right angle for our three basic trig ratios. I have an x here, a 312 here, and a 50 degrees right in there. All right, there we go. All right, so again, our first step, writing down our information. What do I got, right? Again, the easiest one is the angle. So I got theta is equal to 50 degrees. All right, now again, finding my sides. Which side do I have? I always look for the hypotenuse first, which again is always across from my right angle. And it turns out I don't even have it. All right, so no hypotenuse. Looks like I got the adjacent and the opposite here, which is which though? Again, then I go to my angle that I'm looking from, my 50-degree angle. I go across from it. That 312 is going to be my opposite. All right, opposite, 312. Which then, of course, x is our adjacent because it's the side beside the angle. So there we go. I've got my written information. Now I'm on to which trig ratio do I have to use. All right, so again, I have memory keys. Sine on highway. Nope, don't have the hypotenuse. Cozy at home. Again, don't have the hypotenuse. I'm down to my last one here. Tan ratio, tan on arms. I got to use the tan ratio because I have the opposite and the adjacent. All right, so tan theta, again, just writing down here, on arms, so opposite divided by the adjacent. Okay, third step, plug in my information and solve for x. So the angle here is 50 degrees, so I'm going to have a tan 50 degrees. All right, make sure I get things lined up here. My opposite's on the top, so that's a 312. X is on the bottom. There we go. That's my adjacent. Once again, I can find tan 50 degrees, plug that into my calculator. What do I get here? Tan 50. I get 1.19, so we'll put that one right here. All right. So again, this is the spot, which is especially important when you have an x in the denominator, where I'm going to create a fraction equaling a fraction, so that I can get everything sorted out by cross multiplying. All right, so that means I'm going to take 1.19 times x. All right, and then on the other side, I got 312 times 1, which is just 312. All right, still not done yet, unfortunately. I just have to divide by my numerical coefficient here. So I'm going to divide each side by 1.19. And let's see, I'm thinking my x is going to be 200 and something. So I take 312 and I divide it by 1.19, and I get 262.18. So again, following our steps is the same each time, writing down your given information, figuring out which trig ratio you have to use, subbing in your information, and then solving for x. All right. Again, you got to use the 3 basic trig ratios to solve for triangles. But again, we do have those other reciprocal ratios that you now have to worry about. All right. So that is, again, hopefully a little bit of review of solving for the length of a side. At 10 o'clock, our next lesson, we will be looking at solving the angles inside of a right triangle. All right.